Hi everyone, it's Ajanette, and I am here to go over a basic overview of research methods, specifically what's going to be relevant to our lab and our empirical studies that we're going to be conducting. And so this is meant to give you a really broad overview of what we're going to be doing. It can be intimidating. Some of you might be scared shitless by the time I'm done. Some of you are like, okay, those terms sound familiar. Great, we're going to build on that. Some of you may be like, I have never heard any of the things that you're talking about before. And that's problematic because you should have learned some of these concepts in introductory psych or soc. And you would have been building upon these concepts in every psych class that you've taken with us. And then ideally in your statistics class, they would have really been emphasized and discussed. So if not, we're going to start from the ground up, and we're gonna offer you those building blocks to be successful. Okay, so first of all, you should know by now that we kind of have two separate courses involved in this one course. One is your lecture component, which is like any other course that you take. It's like any other 3-unit course. You're going through the textbook, you're learning terms and concepts, you're taking tests on them, you do assignments relevant to them. But in this class, you also have a lab component. Now, it can be a little bit kind of misleading because you're still dealing with a basic kind of 3-unit course, but you're not, because within those units you have lab units and lecture units, and your lab units are applied. So much like you would with a biology lab or an anatomy lab, you go into the lab and you do stuff that's specific to the lab, and it's not just learning concepts and testing knowledge, it's applying that knowledge. And so that's what you're going to be doing in the lab component of this course. And so over the course of the semester together, we're going to be conducting 3 studies. The first study, you are going to serve as the participants, and you will then write a paper on the study. So what we do is we collaborate across all sections of research methods. All students will participate, we aggregate that data, and then we run an analysis on the overall data. And so our sample includes all of the data gathered from all the sections of research methods being taught in any given semester. And you're going to then write a paper on that data analysis as if you are the researcher. So that first paper is what we call a mini paper. And it's a mini paper because you do not have to do it alone, and you do not have to use as many empirical sources for your foundational research as you would otherwise have to be utilizing in a traditional paper. So it's going to be a shorter paper, not as many sources, and you're doing it collectively as a group. So for the mini paper, you still are going to be required to conduct your own statistical analysis. So with the data that's collected across all the sections, you'll run an independent measures t-test to test the research question and see if in fact there were significant differences between the 2 groups identified in the variable. Then you're going to write a paper. You're going to start that paper with an introduction, doing some background research and kind of laying a foundation for your research question. Then in your method, you're going to be outlining your study design. In your results, you're going to be outlining your results, statistical results, and then in your discussion, you're going to be analyzing those results. So this paper and all other papers that we do in the class are going to be written in accordance with APA guidelines. So your APA manual will be your best friend in this class. Although we don't have a required textbook, you are required to have the APA manual. If you are a psych major, which I trust you are taking this class, you are going to utilize this manual throughout your academic career. So just become very familiar with it now. And part of your APA module you'll actually be reading the different chapters of the APA manual, and you'll be applying some terms and concepts. So the second study that we're going to do is going to be a non-experimental study. So specifically, we're going to do a correlational study, and we're going to look at the relationship between multiple variables. You'll select the variables that you want to examine. You'll also be contributing to the design of this study, and you'll be participating in the data collection, not as a participant, but as a researcher. Then you'll be expected to run the analyses, and you'll write your own individual paper. Finally, we're going to do an experiment. Experiments will be designed as groups, so you'll have a lab group that you'll be working with. You'll be designing a 2x2 between subjects design, and you'll be running an analysis to analyze the results, which will be a two-way independent measures Anova. And because this is a between subjects design, we know it's an independent measures Anova. And then you'll be analyzing the mean effect for your first independent variable, which we call factor A, your mean effect for your second independent variable, which we'll call factor B, and your interaction between those variables. And so hopefully those terms and concepts are familiar from your statistics class. If not, we'll teach you those concepts. It'll be a little bit more challenging, but definitely not impossible. So let's go on and talk about some kind of key concepts, right? Like I'm throwing around terms, and some of you might be familiar with them and some of you may not. So let's talk about some building blocks, what you should have learned in other psych classes. You should have been exposed to the scientific method, right? And we'll cover that a little bit in this overview video. You should be able to know the difference between a sample and a population and why it's so important to have a representative sample. Additionally, you should know the difference between sampling and assignment. So we talk about random sampling, and sampling is the method by which we recruit our participants. And random assignment is referencing the method by which we assign those participants to the groups within our study. We're going to talk about different data structures involved in studies, and specifically I draw attention to the difference between a correlational data structure and a comparison data structure. Two very different approaches, both in design and statistical analysis. But in the correlation, it is a very specific data structure where all of our data is measured data. There is no comparison groups, right? In a comparison study, we have different groups of participants and or data, and we're comparing differences in a measured variable across those groups. You should know the difference between an experiment and a non-experiment. There are a variety of non-experimental studies, but experiments have very specific requirements, and we're going to go over the basics of that, and then we'll reiterate it throughout the course. And then different types of non-experimental designs that you may have heard of or been familiar with: case studies, survey research, quasi-experimental designs. We're not going to do any case studies in this class, but we are going to look at some survey research. We'll be using a survey study for our correlational study, our non-experimental study. And then quasi-experimental designs might be involved in the mini paper, but a quasi-experimental doesn't meet the threshold of an experiment, but it's still a comparative study, okay? And we're going to learn about the basic components of a study. So you should be able to identify what a variable is, what your IV is, what your DV is. When it's not an experiment, we might call that a grouping variable or a measured variable. So we're going to go into some of those a little bit here in your overview. And then, of course, throughout the course and semester, we'll go over these things in greater detail. So you also need to come to the class with some basics, some basic statistical knowledge, right? You should have learned the difference between descriptive and inferential statistics. Both will be utilized in this class and in your paper. So you'll use descriptive statistics when you're describing your sample, right, to determine whether your sample was representative. And so you're going to do that in your method section. You'll be using inferential statistics in your results sections of your paper when you're actually doing your hypothesis testing, determining if in fact there were significant findings, and then you'll be presenting those findings and analyzing those findings in the discussion. Now, you should know different scales of measurement because different tests require different scales of measurement, or different scales of measurement of your variables warrant different tests, okay? You should have learned measures of central tendency, the mean, median, and mode. We will be using those appropriately in the results section as we're describing our statistical analyses. You'll be using measures of variability. We don't necessarily report those in these papers, but we need to understand that behind the scenes, that's effectively what we're comparing between groups is often means and/or variance, right? You should have a background understanding of what hypothesis testing is, and effectively this whole class is built on hypothesis testing, right? We are testing hypotheses 3 times over in 3 separate studies, and you're presenting the results of that hypothesis test in those papers. Now, hypothesis testing is all based on probability theory, central limit theory, our theorem. You would have been exposed to distribution samples or sampling distributions, and you know that when we do a sampling distribution, even if the sample starts as a skewed distribution, sampling distributions, pretty much assuming the sample was large enough, they're going to result in a normal distribution, which allows us to actually test a null hypothesis and find out if in fact there are significant differences, or if in fact there is a critical result that lies in the critical region. And so we test based on our alpha level. In this class, we're going to use a 5% alpha level, so P is less than 0.05. Hopefully that's sounding familiar to you. And then the inferential techniques you'll use in this class are the t-test, a Pearson product moment correlation, and a two-way Anova. And ideally, you're all familiar with those. And if you're not, go back and review from your stats course, but you will be running those analyses in SPSS. So you don't necessarily need to have those formulas memorized, but you kind of need to know the basic structure of those studies and what's involved so you can enter it correctly into the system. And then we'll be writing results consistent with APA. So this class may not go into all of these things in as much depth as you went into them in statistics, but we basically will completely apply hypothesis testing in this class. And you're writing your results. Ideally, you started practicing that in stats. You didn't just write out a mathematical answer, but you actually wrote out a narrative answer and explanation of those results. I'll give you a formula to follow, and we will build upon that here in this class. Okay, so let's talk a little bit about the scientific method. So scientific method starts when we become curious about a particular question. Curiosity is a beautiful thing, right? It inspires science, it inspires art, it inspires adventures, travel, relationships maybe, right? Curiosity is a beautiful thing. So we become curious, and we say, I wonder, and we might create a question. We're going to follow a scientific method. It has to be a testable question. So we have to be able to put the question to the test. So scientific method is really important. Psychology is a science. And now, this can't be a question like, is there a God? We can't test those things, right? So scientific method is applied to objective questions that allow for a testable hypothesis and a scientific objective method by which we can observe data to answer that question. So we have to form a testable question. Then we do background research and we say, okay, what does the literature already say? What do scientific journals already say? What research has already been done about this particular topic, and specifically this research question? Now, we might have a research question that's new, adding on to the data that we already have. Great, or the knowledge we already have. So then you're going to build a foundation and say, okay, what has been done about the overall topic? What methods have been utilized to study the topic? How can my research question fill in gaps in our knowledge? Based upon that research, we will create a testable hypothesis. And that hypothesis will be our prediction of what we expect the results to be. And then we'll test that through designing a study. So we will design and conduct studies, either non-experimental or experimental studies, that will allow us to test that hypothesis. We will collect data based upon that study design and analyze that data using appropriate inferential statistics. Then, based upon the results of that, we will draw a conclusion. Was there enough research to support our hypothesis or reject our hypothesis? And then we will present those findings in an APA paper or a research poster or both. And so that is basically how the scientific method does it. People read our papers, then they turn around and use those papers as inspirations to maybe inform their curiosity. Oh, well, they discovered this. Maybe I wonder about this. And then I'm going to build on the existing research that exists. And that's why it's often a cycle, right? Because we build on one another's knowledge. So you should know the difference between a sample and a population. The population is the group of people overall that we're looking to draw conclusions about, right? So maybe I want to understand what teaching methods are most effective for college students. Those might be very different than what teaching methods are appropriate or most effective for kindergartners. Actually, they're kind of similar. But my overall population is all college students. It's absolutely impossible for me to study every single college student that exists in the world. So instead, I recruit a sample of participants. And if my sample is large enough, and if my sample is representative, then I know that basically the patterns I'm seeing among my sample likely exist among the larger population as well. But again, I have to make sure my sample is representative. If my sample is diverse and includes people of diverse gender identities, if my population is diverse and includes diverse gender identities, diverse ethnic groups, diverse age ranges, then my sample should represent that diversity as well. And then based on the central limit theorem principles, based on what we know about sampling distributions, then we know that if our sample is large enough, and about 30 is that trigger point, then statistically speaking, we know our sample is going to approximate the population, and it's going to represent a normal distribution that we can be utilizing to test, to do inferential testing. So let's talk about sampling as opposed to assignment. So random sampling, again, sampling is the method by which I recruit a sample, a subset of the population. I can study a sample because I recruit a manageable number of people. It's almost nearly impossible for me to study an entire population, but I can definitely study a sample. Random sampling is when every potential person has an equal chance of being in my sample, has an equal chance of being recruited, and it's completely random. There's not any particular bias or strategy for how I'm sampling. And random sampling allows the greatest opportunity for true representative samples and for my conclusions to be most valid. And so you'll learn all different types of random sampling and non-random sampling, probability and non-probability sampling. But I do want to make sure I'm differentiating between random assignment because people get them confused. Random assignment refers to the method by which we assign our sample participants to groups within the study. So we have an overall population from which we derive a sample. Then we have a sample in our specific study, and then we divide that sample into different groups, or we determine the sequence that those individuals are exposed to our particular study conditions. So the most basic is when we divide the sample into a control and a treatment group, or a control and experimental group, and then we make comparisons between those two groups. So make sure you keep those separate in your head. You'll talk about them more as you progress through the class. Now let's talk about the different data structures in statistics. So correlational studies should be familiar to you, that they include all measured variables. So when I say measured, not all variables do we take measurements for, okay? Sometimes we do, and sometimes we don't take a measurement to assess a grouping variable. But when you have a correlational study, you're not comparing groups. So where we divide them in between groups, we're going to make a comparison between those two groups. This is a comparative study, but not all studies do that. Some studies just stay up here at the sample and they never break them into groups. So we're taking measurements on each participant, and we're focusing only on comparing the pattern, statistical pattern that exists between those measurements. We're not necessarily breaking them into groups and then comparing the groups to one another. And so I want you to know the difference. A correlational study, there is no breaking people into groups. We're not comparing groups. All participants provide the same exact data. So we have no independent variable, no grouping variable, and that all the variables we're examining are measured variables. And we're merely looking at the statistical relationship between these variables. Now, the most common correlational technique is Pearson product moment correlation. You should have studied that in statistics, so you should know how to calculate an R value, and we'll go over that a little bit more later. And then when we're talking about comparative data structures, you're comparing groups. That can be non-experimental, right? Where instead of us assigning them to groups, they already come in groups. Maybe we're comparing LGBTQ students to non-LGBTQ students. Maybe we're comparing Democrats to Republicans, right? So they already come in a predetermined group. We're not randomly assigning them to groups. In that case, it's a non-experimental study. If we are randomly assigning them to groups and we are controlling all other potential confounding variables in our design, we're using control and manipulation, it's an experiment. Now, notice the difference in the terms. So I definitely still have one variable, that's our grouping variable, that determines which group they're in. So if I said Democrats and Republican, my grouping variable is political affiliation. And then my conditions within that grouping variable are Republican versus Democrat. If I'm saying LGBTQ status as my grouping variable, and I have LGBTQ students compared to non-LGBTQ students, if I had, any other where I was comparing, like, let's say, high school class, right? That's my grouping variable, and then my conditions within that grouping variable would be I'm comparing freshman, sophomore, junior, or senior, that kind of thing, okay? Now, we call that a grouping variable, so the variable that determines which group they're in, and then the measured variable is what we would compare across those groups. Maybe I'm looking at self-esteem between self-esteem based on high school class, right? So I'm comparing the differences in self-esteem between freshman, sophomore, junior, senior, okay? Experimental variables, I have to have a grouping variable that I can randomly assign. It doesn't come predetermined. And so that can be anything. If I'm looking at the value of tutoring, and I can randomly assign students to get tutored or not get tutored, and I'm comparing their success. Or if I'm looking at the effectiveness of an applied research lab, and I can say, okay, students that had a lab versus students that don't have a lab, and I randomly assign them to a lab or not a lab. If they already come having taken a class, that's different, right? That's a non-experimental study. So if it's something I can randomly assign, then it can meet the qualifications for an experiment. And then the statistics that we'll use in this class, now there's a whole host of statistics that we can use for this kind of comparative data structure, but for this class we'll use that independent measures T and a two-way ANOVA. Now, another thing that you have to consider is what scale of measurement you're using. So you should have learned this in stats: nominal, ordinal, interval, and ratio. And so when we talk about nominal data, they're different in name only. It's categorical, it's qualitative differences. Ordinal, they're now ranked, but there's not equal distances between the ranks. Interval, they actually now have not equal distances between the ranks, so the difference between, the highest between, 8.2 and 8.3 is the same as 8.3 to 8.4 type thing. And then ratio is going to be anything where there's a true zero, and so when we're talking about scales of measurement, they're important because our grouping variables are always nominal. Our measured variables can be a number of different ways that we measure them. How we measure them in the scale of measurement, whether it's an ordinal, interval, or ratio data variable, determines what statistical test we can use. So for a t-test, we have one nominal variable, that's our grouping variable or independent variable, and then we have one measured variable, and the scale of measurement has to be interval or ratio data. So we compare an interval or ratio data variable between the two groups of the nominal variable. Two-way ANOVA, we have two nominal variables and one measured variable that's interval or ratio data. So that's why it's important to know your scales of measurement, because certain statistical techniques rely on certain scales of measurement. We can only do certain things with them. Additionally, when we talk about your measures of central tendency, your measures of variability, those may or may not apply depending upon the scale of measurement. Mean and median don't apply to a nominal variable, but they do to the others. And so we need to talk about those things, and you need to kind of understand the scale of measurement. So the basic overall question you need to ask to see if something's an experiment or non-experiment is, was random assignment used? Were they randomly assigned to groups? If they were not, it's automatically a non-experimental study. Now, there could be a quasi-experimental study, right, where we're still making comparisons between groups, but there's something about the participants where they already came pre-selected in a group. And in psych, we do that all the time. There's lots of things where ethically we can't randomly assign them. So if I'm studying like self-esteem differences in sexual assault survivors, or comfort with intimacy in sexual assault survivors, I can't randomly assign someone to survivor status, right? That's unethical. So they already come, in those groups where they are a survivor or they aren't a survivor, right? And I'm not ever going to be able to ethically study sexual assault, the effects of sexual assault on anything through an experiment. So a lot of the research that we use in psychology, especially with those kind of really clinical circumstances, even studying, differences across, people with mental illness, and different types of mental illness, those are things that I can't randomly assign. And so I'm relying on non-experimental research or quasi-experimental research. Every research design has trade-offs and advantages and disadvantages. Yes, experiments are often held as the gold standard. They're the only way by which we can say something causes something else, where it's a true study that we can do a cause and effect research question. However, not all topics can be studied that way. And additionally, just because it occurs in a lab environment doesn't mean it's always going to occur in the real world. And so there's trade-offs for experiments. Additionally, for non-experiments, there's trade-offs, right? We can never really say that X causes X because there might be other factors that we didn't control for that might influence outcomes. But you should be able to assess by reading a question or reading a study whether it was experimental or non-experimental. And then, of course, for our own studies, you're going to be describing that, right, in your method. Okay, so just another way to compare some of the benefits of experimental versus non-experimental. First of all, we can say cause and effect for experiments. So the IV caused a change in the DV, and for quasi-experimentals, we cannot test that cause and effect relationship because we did not control for participant differences, so we don't know maybe something about the participants caused the differences, because there's always that possibility that some third variable exists that we didn't account for in our study. So we will conduct an experiment. Our final study in the class will be an experiment. Experiments have two requirements: control and manipulation. So first of all, in terms of control, what do we have to control? We have to control both the environmental factors that might influence the outcome, and we want to make sure that both groups are tested in the same exact conditions and there's not some outside random environmental factor affecting one. We can't test one in the daytime and one in the nighttime, or one in a room with windows and one in a room without windows. We have to make sure they're both treated equally the same and the conditions are all managed and controlled for. We also have to control participant factors. If we're looking at the effects of in this particular example, we're looking at the effects of the color of the cup and whether more drinks are sold if you sell the drinks, if you serve the drinks in a red cup as opposed to a blue cup. And so we're comparing product sales between those two different colored of cups. In this one, we're looking at how much sleep did they get, and then what was their reaction time. So we can actually control this and randomly assign people to get only 2 hours sleep versus 10 hours, and then we can compare reaction time. Do they have quicker reaction with more sleep, or don't they? And so we are randomly assigning people to groups. If we randomly assign them to groups, we're controlling differences in participants, and we're not just putting all the quick participants in one group and the not so quick participants in the other group. And that random assignment allows us to control those participant differences. And then finally, you have to have manipulation in an experiment. So we manipulate variables, not people. Really important to recognize that. This isn't like your manipulative X. This is manipulation as, we alter it. We determine for a particular variable, we determine what the variable is going to be, how many conditions they're going to be, what those specific criteria are for those conditions. So we manipulate the independent variable. We don't manipulate the dependent variable. We manipulate the IV. So the IV, we determine how many groups, what the criteria is for the groups, and then we randomly assign who gets to be in what group. For the dependent variable, it's not manipulated, it's measured, and that's the variable that we assume is affected by our manipulation. So what we're testing is, does our IV or our causal variable create differences in the DV? So is the outcome in the DV based upon the different groups or conditions of the IV? So sometimes you might hear that referred to as a manipulated variable and the causal variable compared to the measured variable and effective variable. If it's not an experiment, then we would use the words grouping variable and comparison variable, or still measured variable. So one other factor when we're talking about groups is we can have a within subjects design where all participants are in every condition of the study. So let's say we did, we assessed your anxiety levels, and then we did a meditation, and then we assessed your anxiety levels again. So same group of people, I had 10 participants, anxiety measurement pretest, then our treatment, which is a meditation, and then I'm testing your anxiety levels again. And in that case, I'm going to compare the same people in two different conditions, pre-meditation, post-meditation. And I'm going to see if the meditation caused a change in anxiety levels. That's what we call a within subjects design. When the same people are being measured twice, we call it also repeated measures, right? They're being measured twice, repeatedly, once and then again. A within subjects design uses a repeated measure statistical analysis, or you can randomly assign them to two separate groups where you have a group that doesn't get meditation compared to a group that does get meditation, and you're comparing anxiety levels. That is what we would call a between subjects design, where you have different people in each condition. And both can be experimental, right? But within subjects, I might want to have half the group, I'm going to do a before and after meditation for the whole group. But they can both be experimental, and we'll get into a little bit later in the class whether or not are different ways that you want to sequence your sample so that we can make sure that I'm sorry, I'm hearing my daughter leave, and so I'm a little distracted at the moment. Give me a second. I'm going to go say goodbye. Okay, I'm back. Thank you. Anyway, there's order effects, and so we want to control for those order effects, and so you'll learn more about that. Typically, your between subjects design are simpler, more straightforward. We will typically utilize between subjects designs for the purposes of this class. But later on down the road, you might design a study with a within subjects design. It really depends on the research question, what research has been done, and what other designs have been utilized to determine which design makes the most sense. But for our purposes, introductory level research methods between subjects are simpler. Okay, so I'm not going to go into all of the measures of central tendency, but you should have learned mean, median, and mode. And it's really important. So we have here two different symbols to represent mean, because one's for a sample and one's for a population. Median is often symbolized just MDN, and then mode is just written out as mode. And so your mean is effectively your average, your median is effectively your middle number in a data set, and your mode is your most frequently occurring. You will report all of these descriptive statistics within your results section. And then additionally, when we're talking about variability, variance is often used within our formulas for inferential statistics. Standard deviation and range. These are important descriptors, right, where I'm looking at what's the average variability within my sample. And then I'm looking at, so measures of central tendency is really how similar are the data points, and measures of variability are how dispersed or different are the data points. So variances is how much the scores vary within the sample. Standard deviation is the average distance from the mean, and range is the high to low point. When we do hypothesis testing, we actually are basing it on the normal distribution. So ideally, you're really familiar with the normal distribution. A normal distribution, your mean, median, and mode all are equal to one another, and they represent the peak point of the curve. And then the curve is completely symmetrical on both sides of the mean. And what happens is not about 50% of your data point is above the mean and 50% of your data points are below the mean. We have these standards that exist where about 70% of the population falls within one standard deviation of the mean. About 95% of the population falls within 2 standard deviations. So the extra 5% or so is the critical region. And then about 99% of the population falls within 3 standard deviations of the mean. So it's rare that people fall outside these standard deviations, and so we use this as a basis of testing. Well, is it falling kind of within the normal reasonable range, or is it falling outside of the range, which becomes our critical region? So that's what we're actually testing. We have alpha levels of 0.05, 0.01, and 0.001 commonly used in research. We're going to adhere to 0.05 for the purposes of our class because it's easy for us to conceptualize and we're just building those practice skills in. So we're going to look at what exists outside of 2 standard deviations, okay? And we're going to say our critical region is that extra 5%. So 95% falls within those 2 standard deviations. 5% falls outside of those standard deviations in the critical region. So what we want to know is, are there significant differences? Are our results less than 5% likely to occur? If so, then it could just be chance, right? If they're less than 5%, then they're critical, they're significant. If they're greater than 5%, then it's likely just due to chance, and they're just like everybody else in the normal population, okay? So in inferential statistics, we actually test the null. So we're saying, yeah, there are no significant differences between the groups, right? Or there's no significant difference between the sample and the population. And we're literally testing the null hypothesis. We can't test an alternate hypothesis per se because there's an unlimited that could exist, but there's only one null. So we can test that. So we either reject the null or fail to reject the null. If the null is true, it's going to stay within the 2 standard deviations. If the null is not true, then it's going to fall in the critical region. I'm going to do a stats overview with you that goes into this in a little bit greater detail that helps you understand that with more clarity as well. And it'll come up again when we're actually doing our analyses for our studies, okay? When we reject the null, we don't report rejecting the null in our papers. We actually say there were significant differences, or we say there weren't significant differences. So when we reject the null, there are significant differences. When we fail to reject the null, there are no significant differences. So this goes into a little bit detail. So if it's in the critical region, P is less than 0.05, we reject our null hypothesis represented by the H subset 0. We fail to reject the null when it is not in the critical region and our P is greater than 0.05. So when it's less than 0.05, we reject the null, the score is in the critical region, and we say there were no significant differences in the DV based on the IV. When it's over here in this range, we would say P is greater than 0.05, the score did not fall in the critical region, and so there were no significant differences in the DV based on the IV. Now, for all research, you can be wrong. There's a type 1 error and a type 2 error. And this is something you should have studied in stats, but with a type 1 error, we say, oh, there were significant differences, but really, we are wrong, okay? So we reject the null, but we're wrong. In the type 2 error, we don't find the differences, but they actually do exist. So we fail to reject the null, but we're wrong, okay? They're both errors in conclusions. They're both wrong conclusions. We say it's better to make a type 2 error than a type 1 error. So just things to think about. So the tests you're going to use are a t-test. So a t-test is a means test. I'm comparing differences in means between the two groups, and I'm saying, is our difference reasonable? Does it fall within the critical region, or does it not fall in the critical region? There's different types of t-tests. The ones that we're going to use are an independent measures t or an independent sample t. That relies on the between subjects design, where you have different people in each group. All t-tests are comparing two groups. So you're comparing LGBTQ to non-LGBTQ, Republicans to Democrats. It can be experimental or non-experimental. It's all, did we randomly assign or not randomly assign? If we're not randomly assigning, then it's non-experimental, but we're still going to be comparing a grouping variable and a measured variable between those two groups. We're also going to do a correlation. In this case, you're going to do a Pearson product moment correlation for this class. Correlation techniques are very specific, where we really, just like I said, there's no comparison between groups. We just have one group. We collect the same data for all groups. The participants are, same data for all participants. Participants are not treated differently. And we observe we measure two or more variables from those participants, and just as they naturally exist, no exposure to anything. And then what we're doing is we're comparing, is there a relationship? Is there a pattern? When we plot those on a graph, is there a pattern that exists? So we have to have at least 2 scores from every individual in the study. We can plot those scores. We're not controlling or manipulating anything. We're not comparing groups. We're merely looking at the statistical relationship between the two groups. You may have seen different types of correlations where you have a positive relationship where both scores are increasing together or decreasing together. You might have a negative relationship where one score is increasing and one's decreasing, or one's decreasing and the other's increasing. Or you can have no correlation at all. You can also determine, so not only do you have the type of correlation, but you can have the strength of the correlation. Is it strong, weak, moderate? And so that's how closely they're packed together. So you'll learn about interpreting the different types of correlation as well. So you can have positive, negative, or no correlations. You're going to be using a Pearson product moment correlation, which is the R test. And so you don't have to, again, memorize the statistical formula. You just need to understand the concept so you can enter it into SPSS correctly. And then finally, you're going to be doing a two-way Anova, which is a means test as well. It is a comparison test where we're comparing differences in measured variables or DVs between two groups. But you're actually going to be comparing 4 different groups because you're going to have 2 separate independent variables. So in a two-way Anova, you have 2 IVs and 1 DV. And we're going to specifically do a 2x2 between subjects experimental design. So it'll be a 2x2 independent measures Anova. You're going to have 2 separate independent variables, otherwise known as factors. Each IV is going to have 2 conditions, so ultimately you're going to have a total of 4 conditions. There'll be 4 separate conditions, and you'll be looking at 1 DV that has to be a scale variable, so that's interval or ratio, different people in each condition, and you're effectively going to be able to answer 3 questions. So a two-way ANOVA allows you to answer a question about each of the two independent variables, as well as the relationship or interaction between those variables. So we're going to ask, is there a main effect of the first factor, or IB? Is there a main effect of the second factor? And is there an interaction between those two factors? So does the effect of one depend on the other? And the effect sizes are used, so effectively our significance tests or our hypothesis tests tell us whether there were significant differences. Effect sizes tell us how big those differences were, the magnitude of those differences. And so the type of effect size you use depends on the type of test that was conducted. So Cohen's d is used for z-scores and t-tests. R-squared is used for correlation and can be for ANOVA. And then eta squared is used for, or partial eta squared is used for your ANOVA. And just like correlations can be small, moderate, and large effects or strengths, your effect sizes have small, medium, and large boundaries as well. So this is kind of a guideline for R squared, Cohen's d, partial eta squared. All of these tell us what the threshold is for whether it's considered a small effect, a medium effect, or a large effect. You can also use a confidence interval, and a confidence interval is automatically done by ANOVA for some tests, but it tells you that the estimated population mean is expected to fall somewhere between this range and this range. So it's like field goal posts for us. And it tells us, with a certain degree of confidence, I can predict the population mean falls within these ranges. Okay, so that's pretty much it. Now, hopefully I didn't scare you too badly. Hopefully some of this sounded familiar. If some of it sounded familiar, but you really don't completely understand all of it, that's okay. You're right where you need to be. If you're in a place where you're like, it's in there somewhere, but I'm just not sure that I could like regurgitate and tell you all of it, that's okay. We're going to spend this class digging through what you already know and brushing things off and cleaning it up and refreshing it, and maybe even building in some new knowledge. But that's what this class is for. We're going to work with one another. I'm here to support you, and we're going to get through this as a team. And I just want to reiterate before we go, I want you to know that if you're willing to put in the time, I'm willing to support you. So I will never give up on a student as long as you don't give up on yourself and you don't give up on me. The students that don't finish this class successfully are the students that fall off the face of the earth, the students that give up. Now I get life happens, but life's always going to happen, guys. People, y'all. I want to be inclusive. Some people don't like the term guys, right? Life's always going to happen. And so I have gone through a lot of trials in life, and while I was a student, I've had family members have major health issues. I've had family members pass away. I've had legal battles. I've had health issues myself. My gosh, I had to have my hysterectomy, and I came to class the very same day I was released from the hospital, and I was in class that night. Radiation for my breast cancer. I literally attended a meeting just hours after my radiation. And so I want you all to know that life happens. I will support you if you decide to take a break and manage life, but I'm also going to encourage you. I will support you through those challenges too. So don't give up. Persist in the face of those challenges. I am one of the most flexible instructors you will ever experience in your entire academic career. So it is a great opportunity to get through those difficult times with me. It's a great opportunity to use me to pull you across the finish line when you're doubting yourself, when you're afraid and scared and nervous. That's okay. I've been afraid and scared and nervous too, but I jump anyway. So I want you all to trust me, be willing to jump, and let me be your parachute. Looking forward to a great semester.